Hello, everyone, and thank you for joining us for another live webinar session brought to you by EE Tech and allaboutcircuits.com. My name is Jason Montgomery, and I'll be the moderator for this session. Today's session is brought to us by Omron, and our presenter is Carrie Horan, and the name of this presentation is Time of Flight Sensor for Patient Monitoring. And before I hand it off to Carrie, let me cover just a couple brief pieces of housekeeping. The first thing that I'll note is that you have that Q&A box that's on your screen that you can use to submit questions that we'll be happy to go over during the live Q&A that'll follow this live presentation. And the other thing that I'll note is that if you happen to have any user interface issues, if the slides aren't showing up right, if you can't see Carrie clearly or anything like that, first thing to do is to just refresh your browser. Sometimes On24 takes a minute to get things lined up correctly. You can also message us in the Q&A box with any questions or concerns that you have, and we'll try to help you out there. And we'll always have this webinar available on demand afterwards so that you can catch anything if you want to rewatch this again. And with that, Carrie, welcome, and I'll hand it off to you.
Thank you very much, and good morning, everybody, and welcome to today's webinar. Again, my name is Carrie Horan. I'm the product manager for sensors and modules at Omron, and today we're featuring one of our latest sensing products, our B5L Time of Flight sensor, and how it can work for patient monitoring applications. The sensor uses time of flight method to read distance data in a given environment, and advancements that our engineers have been working on have allowed us to track human skeletal movement in real time. Very exciting features that we're looking to discuss in this presentation, and we'll go over the sensor as a whole and different applications that it can be suited for throughout. So before we begin, I'd like to give a little bit of background information in who we are. Omron has been one of the leading innovators in product development over various industries, and we have a number of divisions within the company across the globe that cover a number of different sectors. We have experience within the healthcare industry already with our division that is produced thermometers and blood pressure monitors, which you may have seen at your local box stores. Our social systems division covers public works devices that can be seen across Japan and other countries in automated vending machines and ticket stations for trains and subways. Our industrial automation business is our largest group, covering needs of automation, robotics, safety, and industrial applications, and leading the way in manufacturing innovation across the globe. Where I represent is our electronic and mechanical components division, where we produce a large number of component-level products for use in all sorts of different industries. From switches to connectors, relays, and sensors, we design and manufacture a huge library of products that can cover all these different industries, from smart home and building, energy, consumer goods, gaming, and of course, healthcare, which we've been making great strides recently in many of our different components, including our time of flight sensor. Across all of our divisions, Omron is committed to improving lives and contributing to a better society. And we hope today we can share our latest products to demonstrate that to you and how our team is hard at work in making it happen through our sensors and sensing technology. So the modern healthcare industry is always in need of innovation, especially in sensor technology, particularly in how they can help with patient care, making it easier, safer, and more reliable. The times of COVID have been a big indicator in how important it is to have a means by which to best care for patients, especially remotely and through automated systems, so that issues and problems can be detected quickly. Modern health needs include ways to monitor patients as they are ill, injured, or in a recovery process. Doctors and nurses may need to monitor patients to ensure that they're staying active enough, that they're not stumbling as they move around the room, they haven't fallen or collapsed, and making sure that they're getting enough movement and not just staying in their bed all day and be liable for some other injuries that may take place. Typical solutions of this type of need generally involve video monitoring, which is an effective enough solution, but it does, however, come with its setbacks. Just getting a video feed of a room will not give any sort of alerts as to the activity of the persons within the room. And any information that does need to be gathered on this, such as for fall detection or making sure that a person is staying active enough, really requires real-time human monitoring, people looking at those feeds in real time. We don't really have a way to yet automatically alert medical personnel when an incident takes place. We do rely on skills of other people involved. But that automated process would really make things a lot easier and a lot more streamlined for healthcare professionals. Moreover, and a big issue for a lot of people is that video feeds do have privacy concerns. Many patients who are being monitored may not wish to be on video, and certainly privacy concerns are a major factor for users today across the healthcare and many other industries. So any way we can put these users at ease can certainly be beneficial to make care much easier in these different processes and as we monitor patients over time. So as we get into this, the industry, we come into our first poll question. What are some of the major innovation needs that you see are required for patient monitoring? Is it those privacy concerns that patients are often concerned with their privacy while under care? Automation, looking for streamlined ways to detect incidents such as fall detection and alerts, as that would make it much easier to sense different emergencies? Or are we looking for smarter sensing? As we mentioned, and as we'll talk about here, our skeletal detection program and our human sensing algorithms would bring many new possibilities to healthcare monitoring. So I'll give everybody a few moments to answer this poll and get a little bit of input into what we're looking for and what we can really focus on as we develop this product. So I'll give everyone a few more minutes, again, looking at whether these big concerns revolve around privacy, automation, or smart sensing. All right, so let's move forward here. So as we look at the patient monitoring applications and patient activity tracking, there are, as we've mentioned, several different solutions that are already available on the market. We have video feeds, which are certainly effective, but they do come with their downsides. Being invasive in those privacy concerns that many people may be facing, video feeds don't always put them at ease because they don't necessarily like being monitored or recorded. Certainly it is necessary, but not everybody is going to have that same comfort level. And of course, it also requires another set of people who are going to be monitoring those video feeds and making sure that a person is not going through any sort of incident. So there's not really an automated system to make those video feeds work to the best of their ability. IR sensing is one that is very common, a very cost-effective solution, using IR sensors to track motion around a room, making sure that a patient is not up and moving around in the middle of the night or tracking their activity. But with traditional IR sensing being a very cost-effective solution, it also can be a very simple solution. These sensors only detect motion. They cannot distinguish humans from inanimate objects. And so they don't really have the ability to have the different algorithms that are put in place for these types of applications. Thermal sensors is another product, coincidentally, that we do also offer at Omron that has been looked at for these types of applications. The sensor is able to detect motion and human presence due to the fact that it's gathering thermal data and reading the temperature changes and warmer bodies of a room relative to the surrounding space. There are also benefit to these thermal sensors, algorithms that can be implemented to distinguish human bodies from other warm bodies that may be in the room. However, the downside with these products is while they are sophisticated enough to detect people in the room and to distinguish human shapes, they are not necessarily sophisticated enough to meet the needs of medical care facilities. One of the biggest questions that we have gotten, one of the biggest drivers that we had into getting this program into patient monitoring applications or getting the sensor into patient monitoring applications is the ability for it to read skeletal motion, sense where the arms and legs are relative to the rest of the body, looking at seeing if they're upright and moving around or collapsed. That's not something that we can get out of thermal sensing or really any of these other products. So while there are existing products that are available for this type of solution, not all of these are something that we're able to get the most out of. And so that's where we come in with our time of flight sensor. So for everyone who may not be familiar, we have done a couple of webinars on this before, talking about the time of flight sensors in general applications or in AMR applications, but we'll go over the concept of it here. Time of flight is a method of sensing that involves reading distance data in an environment by using an LED array or an LED light. The basic operation of this sensor is that the LED array, which is displayed here on the bottom left, bottom left of the slide, you'll see a diagram of how this sensor is working out. The LED lights project outward, and those are shown in red. As it reflects off of the objects in the room, the signal will return to the sensor shown in green and is then gathered by the receiver. The sensor will calculate the time it takes for the LED to reflect outward and back to the receiver, and then the sensor can process that distance data to read where the objects are in the room. The data that we are gathering is over a wide 90-degree field of view with this particular sensor, so you're really getting a full view of the room in front of it. The sensor can effectively use this distance data to map up the full scene of the room that it's in, not only getting a 2D image, but actually able to render a 3D image of the space in front of it. Among other key advantages of this product that we'll go over later on in this presentation is the sensor is not affected by object material or movement. The sensor can just as easily detect a person moving around a room as it can smaller objects on the floor or other walls and obstacles around the room. So certainly something that can be very effective in effectively monitoring a patient as they move around the room and as they go throughout their activity while under care. So with all of that information, we introduce our product, which is in our B5L series, the time of flight sensor. And here's an image of how we have that looking today. So going over our product, the time of flight sensor offers the real-time 3D environment sensing that is capable of detecting stationary objects and human movement in a room. Our sensor operates with a response rate of about 20 frames per second, allowing for near real-time analysis of a room, the activity, anything that is positioned in the room or moving around the room, giving healthcare professionals confidence that the sensor is giving them proper data. The sensor utilizes a 3x4 LED array that we mentioned in the previous slide to work as effectively as possible. And using the data collected by the LED signals, the sensor is not only able to read the data projected into a 2D space, but if you see the 3D image on the right-hand side of the screen, while it's not a full video of the 3D space that you're looking at, it does give a representation of how the sensor is able to collect this data and construct a space that you're able to monitor and look at the people as they move around an office space. As a bit of background into our development, the sensor was originally developed as a key component for automated mobile robotics, logistics, conveyance, and other industrial applications. This was something that we had developed originally as a competitor to traditional Lidar sensing, which is a very expensive solution that many AMR or automated mobile robots will use in their applications as they navigate a workspace and navigate a warehouse space. The time of flight sensor is a much more cost-effective way of making this work, and that is what we have originally found a lot of success in. However, the ability of the sensor to work in these environments has actually gathered attention from other industries, particularly in the healthcare application, for human monitoring. Using just the baseline sensor, we had many companies who were very interested in the fact that the sensor is gathering distance data rather than looking at a video feed and capturing the video and potentially the identity of patients or persons that are on that video. The sensor's ability to read motion in real time is a perfect reason for it. And then, of course, being able to read that distance data to see whether they're upright, laying down, or may have fallen over. The B5L sensor has a number of different advantages that can make it well suited for the healthcare and patient monitoring applications. Number one, the sensor has an exceptionally high ambient light immunity, working in conditions of up to 100,000 lux, and that is direct bright sunlight. This means that the sensor is capable of working in these conditions, direct sunlight, low light situations, because the sensor is just reading that distance data from the LED. It does not require proper lighting conditions for it to work best. So users can be confident that even when pointed at windows or in brightly lit rooms, the sensor ability to read patient activity will not be affected. Its high precision comes from compensated signals within the internal programming that The high precision comes from compensated signals within the internal programming and software developed by the engineers. Because of the different properties and different materials, such as color and reflectiveness, we have these different compensated signals to increase the sensor performance, consistency, no matter what is being detected. We have had many different field testing situations where reflective floors or reflective objects or different colored objects we've done a lot of different testing, and sometimes that has given us different readings in early iterations of the sensor. And our engineers have made sure that in this final product that we have created a sensor that is consistent in detecting all types of different materials at different angles and different lighting conditions due to our compensated signal structure. Thanks to the heat sink implemented by the engineers, the sensor is capable of continuous operation of up to 5 years, giving users confidence that the sensor can really run for a long time without too much monitoring. And lastly, the sensor's ability to prevent interference of up to 17 units is certainly something that we've seen advantageous in many different types of applications. We can have different sensors working in a single space. So in some rooms where there are possibly different angles that need to be gathered or different blind spots that one sensor may not be able to see everything due to the structure of the room, you can have multiple sensors that are working in this space without interfering with one another. In addition to all of this, our engineers are hard at work in developing our skeletal detection software to distinguish human movement and track their skeletal position. This allows for the sensor to effectively be used as a way to monitor human movement. And as we develop the software, we plan on there being additional abilities brought by this product, including fall detection and activity sensing. So with that, we are coming to one of our video clips where we show off this sensor and how it really works. So this right here is a video clip of the sensor in action. We see how it's reading human motion as a person is coming up, getting out of bed, walking around a room. You'll see them as they pick up objects in the room, sit down on the bed, and you can see how well the sensor is able to capture this data in real time and give a smooth feedback to the person who is viewing the video feed and making sure that they're reading the activity well. So you're seeing that real-time performance of the sensor and how well it can work in a given environment. So now we go to our next poll question. As we go into these advantages, what is one of the most important advantages for the time of flight sensor as we go into healthcare operations? Would that be the upcoming skeletal detection program that we will be demonstrating later on in this presentation? High accuracy and distance compensation, being able to read the positions of people, no matter what distance they are or what angle that they're being looked at in the room, working well in bright light conditions, or are all of the above very important qualities for monitoring patient activity with the time of flight sensor. I'll give everybody a minute or two to answer the poll question before we move forward. All right. Thank you very much. So let's go over some of these product advantages in a little bit more detail. And first and foremost, I know we've been talking about it throughout the presentation, but let's talk about how the sensor can work best for healthcare operations due to its non-invasive properties and the upcoming software we are incorporating with the skeletal detection system. So our Omron engineers are driven by the ever-present need for a non-invasive way to read the patient activity. Because the time of flight sensor utilizes this distance data rather than video capture, there is no way for persons to be identified utilizing this software. It is very sophisticated and sophisticated enough to accurately read positioning of even smaller objects in the room, but it is not detailed enough to pick up facial features or identities. So patients and personnel can be confident that the information is kept secret and secure. Now, already we've gotten requests from customers involved in this industry seeking a time of flight solution. So already we know that there was a way for this sensor to work well for this situation. However, the addition that engineers are incorporating into this sensor makes it a perfect solution for patient monitoring with the skeletal detection system. So let's take a look at a few examples of how this looks right now. So this is the first video of our sensor in action. This was one of the first tests that we had done just a couple of months ago. This is our sensor recording a room with a person moving in it. This is no other editing that we have done with it, and our skeletal detection software. So even in the early iterations of how the sensor was able to work, we're able to effectively track the movement of a person, their arms and legs relative to the rest of their body, even as they're walking around the room, as they're turning their body. We're still able to keep track of which arm is the left arm, the right arm, the left leg, the right leg, and tracking all of their movement as they're going around the room. So our engineers were very excited to release this clip and this early iteration of the software that we have shown off to different companies who have been testing our products out. But as we have developed this software a little bit further, this is the most recent iteration. And we have now the ability to detect two different people as they're in the space at the same time. We can see that one person on the right is sitting down, the person on the left is standing. We're still seeing that those distinguished arms and legs as they're moving around. And one other thing I'd like to point out here that we are very excited about is in some cases, especially as the person is getting close to the screen, we'll see that their arms and legs may be slightly obscured. I'm not sure if you had caught that in that clip, but the arms and legs in some cases may be obscured. And that may happen if the person is partially out of frame or if the person is behind a piece of furniture, such as a couch or a bed. It was important for customers we found to be able to read the presence of a human body even when they are not fully visible by the camera. There are certainly going to be ways that patients are going to be around the space and not always going to be fully visible, all arms and all legs, if they're walking behind pieces of furniture. Our sensor's ability to even read and distinguish the skeletal movements as they're behind different objects or partially obscured is something that we have been incredibly proud of and very thankful that we have been able to develop this side of the product well. And we are continuing to work on this and release new demo versions of the software that are available for people to test out. So Omron engineers have been hard at work in developing this software over the past few months. As I said, we do have new features that we are planning to add as we move forward with this development, such as detection of the multiple bodies and people who may be partially obscured. And we are expecting a final release of this sensor this sensor with the full software in March of 2022. Very excited to have this coming up for its soon release. And we're hoping that everybody would be interested in getting some more information on that and hopefully get a demo in their hands to test for themselves. So as we move forward in this software development, we come to another poll question, which is after general body detection, what is the most important feature we can include with the time of flight sensor? Is that fall detection to determine when a patient may have fallen to the ground, body movement analysis for physical therapy, making sure patients may not be limping or stumbling, progress tracking, remembering how a patient may have moved in the past, whether they were stumbling, or whether they may have had issues with mobility and how they are progressing over time, or activity sensing to track how often a patient may be up and moving around, or how long they may be laying in bed for an extended period of time. So I'll give everyone a little while to take a look at that poll and let me know which are the most important feature that we as Omron engineers developing this software can focus as we make this a perfect product for patient monitoring. All right, so as we continue with these sensor advantages, I just want to talk about a few more things in a little bit more detail here, going over some of the advantages that the time of flight sensor has. We have mentioned its high light immunity, being able to work even in direct sunlight. We know that in many ways, when this sensor is being set up for patient care facilities, there are going to be rooms that are very brightly lit, or there could be arrangements where the sensor is going to be looking at a window in order to get the full view of the patient's bed and the patient's room where they're going to be walking around. Because the sensor has this high light immunity and is capable of working in all of these different spaces, I'm sorry. The user does not need to be concerned with brightly lit rooms, backlighting, or windows. We can see on the bottom left-hand side the test data for the different tests on the right-hand side, where we have the pictures of the objects and how they're being detected by the sensor itself. Across the entire spectrum of light conditions, we have very consistent readings. You can see that even in backlight with the sun in the background, we are still gathering effective data from the objects that are in the distance across various different distances. We have marked these different plates out in increments of 1 meter away. And in normal lighting or in backlighting conditions, the sensor is only gathering distance data. So it is, again, as I mentioned before, not in need of proper lighting conditions in order to work effectively. So very pleased to have these results to show to everybody else for the lighting conditions in healthcare applications. And then our high precision and our distance compensation, our high-speed LED driver circuit and good design make this product a highly accurate sensor over the entire range of measurement that the sensor is capable of. We have calculation, software compensation, and 3D space conversion, allowing for accuracy even at these different angles. So on the left-hand side, we show our distance accuracy, being able to measure the distance of an object across the entire range. We can see that the sensor, even up to 6 meters away, roughly about 20 feet, definitely the space of an average room that a patient may be in for hospital monitoring or physical therapy rooms. We're getting very accurate readouts of an object from the sensor in normal light conditions up to 6 meters away. Very consistent readouts. And on the right-hand side, we have viewing compensation as we look at the sensor as it's able to determine the distance of an object even at different angles. So we're looking at the sensor as it's looking at an object head-on, and on the right-hand side of the graph, you'll see how the sensor is determining distance data at 45-degree angles and at 90-degree angles. So we are getting, again, very accurate readings over these different distances, over these different operating conditions. Very exciting to have this sensor performing so well, and why we're looking to reach out to the healthcare industry and patient monitoring applications to get this accurate sensor to be working properly for the needs for patient monitoring. So as we wrap things up and go to our Q&A session, the Omron B5L Time of Flight sensor is just one of the latest developments that Omron has in our sensing product line and for our innovative product solutions. The sensor alone provides many advantages to any industry, including automated mobile robots, industrial, and people monitoring applications. But our continued developments only improve the product ability, especially with our skeletal detection program, especially with the improvements that we have planned ahead. And further development into the healthcare industry is only going to continue our motivation and our commitment to improve lives and contribute to a better society. So thank you all very much. Again, my name is Kerry Horan, the product manager for sensors and modules at Omron. I encourage everybody, if you have any questions about this product or any of our other sensor components, to please reach out to me. My email is kerry.horan@omron.com. Please visit our website to learn more about our components, including our other sensors, switches, connectors, and power relays at components.omron.com. And then while I don't have a link here on this page, I'd also like to plug our YouTube channel, where we are releasing all kinds of videos, our Creative Lab videos, where we are demonstrating many of our different products in action. We have several different sensing products and different components featured already, and we are continuing to put out new videos. We have upcoming ones with our time of flight sensor as well, and we encourage everybody to take a look and learn more about all of our products on these different websites. So thank you very much, and we can open the floor to questions.
Great, thank you very much, Kerry. Can you hear me okay?
I can hear you great, thank you.
All righty, well, thank you, Kerry, for that presentation. And again, everybody, I know we've got a good batch of questions to start off here. Definitely use that Q&A box as we're getting ready to dive into things here. So, Kerry, first question that I'm seeing, what other advantages does this sensor have over other time of flight options in the market today?
So one of the biggest ones, as far as time of flight goes, I mentioned our skeletal detection software and our development plans that we have for it. We feel that that is going to be a big advantage in time of flight. A lot of time of flight solutions don't always have that power to get that type of information from the data that it's gathering. But one of the biggest things that we have found, even as we've showcased this sensor, is that our time of flight sensor, especially running with the software, is not going to require any additional equipment. It's not going to require an extra GPU. So that we have found has been a huge advantage. We've seen other customers who are working with different time of flight solutions who have been finding that the added GPU, that processing power, is not only affecting how their product works, but it's also affecting the price. That's certainly a big factor in any sort of development space, is how much is it going to cost as far as development goes. So our sensor not needing that added GPU, the sensor itself is really all you'll need, has been a big advantage in so far as we've showed this to different industries.
All right, and another question that I'm seeing here, can the skeletal detection software work outside of healthcare applications?
Oh, yeah, absolutely. As far as healthcare applications go, one of the biggest reasons that we have targeted and we were motivated to do the skeletal detection algorithm for it, generally with patient monitoring, you're looking at 1 or 2 people who are in the room. So that's been obviously a great baseline for us in getting the skeletal detection software to work in these types of conditions. It's a little bit more controlled, and typically in these applications, the sensor is going to be mounted to a wall or mounted on a corner and looking at 1 or 2 people at a time. So not only is it a great way to motivate us developing the software for the industry as a whole, but it's also a great way for us to have a clear idea of an easier baseline in developing this software. Now, as we go into other industries and other applications, we're looking at possibly AMR. We're looking at more crowded spaces. Our skeletal detection software is certainly something that could be useful for these types of applications. But it's something that's going to certainly come with our development. As we develop the sensor's ability to process that skeletal movement, while the sensor may be on a moving object, such as a mobile robot and navigating a warehouse space. Or if it's looking at applications where there's going to be a large crowd and you're looking at multiple different skeletons or people and looking at their skeletal properties, that of course is also going to be another added step that we need for development. So it is certainly something that's useful for other applications. But we'll continue to develop our program. And if there are other applications that you're interested in, and it's not just healthcare, but the skeletal detection system does seem to be something that strikes you, please reach out, and we'll certainly work on getting a solution that would be suitable for you.
Perfect. Another question that's come in, Carrie. What support can be offered by Omron when we have the time of flight sensor?
Sorry, can you repeat that question? What's the part that's going to be offered by Omron?
No, sorry. The what's the support that will be offered? Oh. Support offered by Omron when the time of flight, when they have it.
Yes. So as far as when the customer has the time of flight, I see, or as the user has the time of flight sensor. So one thing to point out, especially with the skeletal detection software, is that our engineers have been developing this software, but not completely independently. We have, even right now, are having constant communication between our engineers and the people who are using our sensor and are testing it out. We have actually gotten a lot of input from these users that are testing this out, and have given us advice and given us a good roadmap on what's going to be needed from them and what we can do to best suit those needs. So as far as support goes, our engineers, frankly, are very excited to support anybody who is looking at getting this sensor involved in their application, and especially as far as skeletal detection software goes. So it's not really a matter of if it's going to be offered. It's really how much support are you really looking for from our engineers, because we are more than willing and more than happy to provide any sort of support to get this product working, because our goal here is really, as far as getting this software into your hands, is making your product better and making, hopefully, as your product gets developed fully into its final stages, getting it to something that can really help people and help improve society. So with this sensor and getting into healthcare applications, the support is really boundless by what we'd be willing to help out with. So again, please absolutely, reach out directly of any support that you may be looking for.
Perfect. Next question, Carrie. What is the maximum range of the sensor, and how granular can that measurement get?
So the maximum range of the sensor, while I have given the data that it does work effectively over a large number of ranges, the maximum range of the sensor we put at about 6 meters, and that is how well the sensor can really work in normal conditions, normal lighting conditions and normal operating conditions. We have, of course, seen instances where objects that may be a little bit further away from our listed range may be detected. And it really does depend on the object that's being detected, and really depends on the conditions. So as far as a max distance goes, that can be somewhat tricky to answer, because it will obviously depend on the application. But for general human detection, we've seen it work fairly well at about 4 to 6 meters. For a skeletal detection, we have been testing it out generally at about a 4-meter range, and that's where we've been seeing very strong responses. Obviously, as we get greater and past those ranges, we start to get a little bit of difficulty in detecting things, but it will certainly depend on the conditions of the room. So as any specifics that you can offer us, if you were to reach out directly, we'd be happy to help out with and seeing what we'd be able to provide.
All right, another question that has come in. Do you find customers trying to choose between time of flight and IR array, such as the D6T or are those different applications?
These are going to be different applications. I know with human monitoring applications or person detection applications, both have been ones that we've gotten questions on. Our D6T thermal sensor, for a little another product that Omron has, the D6T thermal sensor is going to be one that's much more cost effective than the time of flight sensor, but it's a much simpler application. And what that's reading, again, is the thermal data, the temperature of the people as they are moving in a room, or the temperature of objects as they heat up. The time of flight sensor, while some of the pictures and videos that I showed did have a color array, that really is still just distance data. It's not looking at the heat map. It's not looking at whether an object is warmer or cooler. So while they can be similar, the specific application really does diverge when you get into what exactly you want to detect, whether that be temperature changes or distance data. So while they can be involved in similar applications, they're going to be two very different sensors.
Perfect, thank you. Next question, Gary, are there licensing fees, additional costs, anything else that we should talk about here?
No, we don't have any additional licensing fees for this sensor and the software. As far as a product goes, this is a standalone. So we have the sensor that will have the software incorporated in it, or at least something that can be installed alongside of it. But additional licensing fees, we won't have any of them with this sensor.
Awesome. Another question, what are the dimensions of the module, the size?
So this is a fairly sizable sensor, especially compared to many of our other products. We have, it's roughly a 50 millimeter height by 100 millimeter width. So it's about the size on the profile, and the front size is about the size of or a little bit smaller than a smartphone, depth of about 50 millimeters as well. So it's a fairly substantially sized product. I wish I had one on me within arm's reach, and I don't. But it's a fairly sizable product, but we're looking at about this large. I wish I had kind of a diagram for you. 50 by 100 millimeters.
Fantastic. Another question, what are the development plans of the skeletal detection software?
So as far as development plans go, we have just released our latest demo software, which we have available. It's something that we have available if you were to reach out to myself or your local Omron representative or distributor, where we can release the demo to you that runs the multiple different bodies, and it does also run a version of an early iteration of being able to detect the position of the rest of the human body, even when it's partially obscured. So we have tests that we've done where waist up, the sensor can still detect the torso, the arms, and the head. As I said, we have right now the plan to fully release the software in March of 2022. Up until then, we are going to continue developing. Right now, our big goal is fine-tuning that multiple bodies iteration onto the software, especially as they're walking close to one another, perhaps getting 3 people being detected at the same time. We are continuing to release versions of the demo software as we get to that final stage point, and continuously working with customers and making sure that they're getting exactly what they're looking for. So as far as a specific roadmap, what we have is that final release date. And up until then, we are continuing different beta versions of this program, different software that we can have customers test out on their own and see exactly how they're going to be able to work for them.
I'm going to combine a couple questions here, Carrie. What is the max distance range for this, and how far can this range be extended?
Again, we talked a little bit about the range, and about 4 to 6 is on the higher end of how the range. 4 to 6 meters is on the higher end of the range of the sensor. As far as extending it, that is a question we've gotten with some of our sensing products. We know that, for example, the D6T, if we bring that one back in, we have gotten questions about extending the range of the sensor beyond what its spec capabilities are. What I can say is that it's not impossible to extend it. There's ways that certainly it can be done. With the time of flight sensor, it's a very new product and it's a very sophisticated product. As far as extending the range to say 10 meters, it might not be, we might not have a simple fixed solution for you. And it might be something that we can certainly reach out to our engineers and see what they would be able to do and see what development we can get. It certainly would be something that it would have to depend on how far that range is looking to be extended. But I'd say nothing is off the table as far as asking. It never hurts to ask. And thank you for asking this question now, and we can see what we can get from our engineers. But as far as how much we're able to do right now, I don't unfortunately have a specific answer for you. But I'm sure that there's always some information we can find as we look into what the application is.
Perfect. Another question. For the time of flight sensor, what's the kind of sensor that's being used on the patient's body? Radar, Lidar?
So time of flight is the sensor that's being used. It's measuring the reflection of the light. It's measuring the time it takes for the light to project outward from the sensor, reflect off an object, and go back to the receiver of the sensor. So as far as the time of flight, it's measuring that time of the speed of light passing through the room and reflecting back to the receiver. So it is similar in concept, at least, to radar and Lidar, where it's getting that distance measurement, but it's using a much simpler concept with the LEDs and the receiver to get that distance data. So Lidar applications are going to be much more expensive solutions. Those are going to cost, a couple $1,000s per. With these sensors, we're looking at much lower cost comparatively compared to radar and Lidar because of its much simpler method using time of flight.
All righty. Let's see here. I've got a couple more questions that have come in. Carrie, are there similar product offerings for basic point-to-point distance measurement within a meter with high accuracy?
We have a number of different optical sensors. One of our optical sensors is our B5W, which is looking at object presence. And it can detect, it does have the accuracy in much smaller applications. It is looking at, it's similar to IR sensing, but also is using an LED and array to detect the presence of an object. The B5W can also detect transparent objects and reflective objects, which is an advantage of other optical sensors. But as far as distance measurement and getting the exact distance of an object from the sensor itself, the time of flight is unfortunately right now our only product offering for that.
All right, and we have a question here about what the initial prototype availability is going to be.
So the product itself, the B5L Time of Flight sensor, that is fully released. We have that available on our website, distributor websites. So we have the sensor that is ready to use and ready to order. The software itself, we have those demos available. Again, we have just released our latest demo either earlier this week or last week we had released it. So those are available as well. We don't have those publicly available. These are just early iterations of the software that we're allowing for testing. But it is something we can get in contact with your local Omron rep, reach out to me, and we'll see what we can do about getting something in your hands, getting a sensor in your hands, and getting it tested. So as far as availability goes, we can get that to you today.
Fantastic. Another question, This person is looking for a simpler time of flight sensing solution that can work under direct sunlight to sense simple distance. Is there anything like that in your arsenal?
Unfortunately, that's similar to the other user who was looking for that answer as far as looking for other distance data. As far as looking at actual distance data, the time of flight, the B5L time of flight sensor is all that we have available at the moment. As far as simple distance data, I wish there is something that we could offer. I mean, we really started big with this time of flight sensor. So hopefully down the road, we will continue developing as we find success with this product. Can you continue developing different versions of the sensor that can detect shorter distances, being a bit smaller, a bit more cost effective, simpler time of flight. But unfortunately right now, this is our product that we have available as far as distance data goes.
Got it. I think that answers another question that we've got there as well. Let's see here. Carrie, can you see, I don't know if this question that I've got up here, is this a good one to go over? Do you want to reach out individually for this one afterwards?
I can reach out individually on this particular question. Yeah, I can do that. I know we're getting close to the end here. Yeah.
Well, that certainly was a very robust and active Q&A, Carrie. I'd love to see that engagement. I know you had a lot of value there to impart to all of the questions that were coming in. Is there anything you want to anything you want to close up with here, or anything you want to make sure that we're touching on before we wrap up the session?
I have nothing else to say. I'm also glad we got all those different questions in. I'm glad that everybody has a lot that they'd like to learn about the time of flight sensor. We still have the screen up there that has my contact information, so I encourage everybody to please reach out. We'll have the answers to the poll questions and obviously take all of that input into consideration, because once again, as far as support goes and as far as input goes, we really value the input of the users. We really value the input of who is actually going to be installing these sensors, who really wants to use them, and what they would like to get out of them. So any questions that you have, any curiosity, any ideas of, we could really use this sensor, but it would be great if it could do this one extra thing, please let us know, because we're always looking to innovate. We're always looking to get new solutions into the hands of users in different industries. So we're very happy to show off this time of flight sensor, show off our new software, and hopefully get something in your hands that you can really make work for your final product. So please reach out to your representatives, and visit our website, and please learn about as much as you can, and hopefully we'll speak to you very soon.
Thank you so much. The thing that I'll say, just being the moderator of this and a lot of other sessions, it's really, I'm always excited to do Omron sessions, because I know that you really are committed to hearing from the audience, talking to people, getting that engagement, and actually working with, responding to, and helping people with the design considerations and questions that they have. So this has been a fantastic session, Carrie. Thank you so much for your time.
Thank you, Max. Appreciate it.
And everyone, we appreciate you joining the session here today. We look forward to seeing you at another live webinar session brought to you by EE Tech and allaboutcircuits.com. If you go to All About Circuits and look in the webinar session, you will see plenty of other on-demand webinars by Omron that you should definitely go check out as well. And this webinar will be available on demand for viewing afterwards as well. Thank you all for joining us today, and stay safe and have a great day.